We are going to get started. We now present Connie Dayton, who will speak on the effects of induced gratitude and pride on children's ability to delay gratification. If you have questions, please put them in the chat box.
Hello, my name is Connie Dayton and I'm a research assistant from Texas Christian University. And today I will be talking about our research on the effects of induced gratitude and pride on a child's ability to delay gratification. In regards to the delay of gratification, we talked to the ability to wait for a reward instead of immediately receiving it. There's been lots of research to show that this is an important predictor of future outcomes for children. Additionally, there has been lots of research in the type of strategies that children use during this time to delay gratification, such as looking away, focusing, and so on. But a new body of research has suggested that emotions may play a role as a constructive strategy during this time. And this is what we wanted to focus our research on. The sample size was 4 and 5-year-olds, and they were asked to do a drawing task before of the delay of gratification. This drawing task had 3 conditions, and they were randomly assigned to one of them. The first condition was pride, where children were asked to draw whatever they wanted and they were given praise after. The second was gratitude, when they were asked to draw something they were thankful for and then talk about it. And the last one was our control condition, where they were given a black crayon and asked to draw 5 lines and were given no feedback afterwards. After this drawing task, they did the delay of gratification task, which was where they were given an award and asked to wait 15 minutes to receive more of the award, or they could have immediately. The awards consist of things such as goldfish or fruit snacks and so on, something that was right in front of the children's faces and they could see it all the time. After the study was over, we coded for 2 things. We coded for the time that they were able to delay gratification, as well as the behaviors that they did during this waiting time to delay the gratification. Our results showed that there was no significant difference in the amount of time that each condition was able to wait. However, children in the pride and gratitude condition engaged in more distractions compared to the control, and the distractions consisted of these strategies that we use when delaying gratification. Overall, this shows that the positive emotions do play a role in delay of gratification. Although all the children were able to wait the same time, no matter what mood they were in, the types of strategies that children in the more positive emotions, such as pride and gratitude, chose was better strategies overall. By better strategies, we refer to focusing attention away from the objects, because the children, their want decreases because their mind is not focused on the object. Overall, we can use this in the real world by teachers and parents implementing these strategies to generate more positive emotions during these challenging situations to delay gratification. I want to thank TCU Faces Lab, as well as Deborah and Dr. Ikas for supporting me during my research. Thank you very much.
All right, does anyone have any questions? All right, Connie, how did you get interested in this research?
Well, I become interested in this research because I really love children. Like, that's my main focus of my research in the future. And something like delay of gratification, I think, is oftentimes overlooked. And the marshmallow experiment is a very famous experiment. And I learned about it in my developmental psych class my freshman year. And I just became greatly interested in, like, what other factors could influence this as well as just like them waiting. Like, is there emotion play a role? And that's what kind of like heightened my interest for this topic.
Are there any follow-up experiments or research planned?
Not at the moment, but I do want to see if gender or if, as well as disabilities, I'm very interested in the autism community and see if how that affects delay of gratification as well. So I think from this topic, I can expand in other areas about differences, yeah.
Excellent. Are there any more questions? We've got a couple of more minutes. Well, I have another one. Were your results what you expected, or did you expect something different?
They, to an extent. So I did expect that strategies would be different when they were in a different mindset emotionally, but I did expect there to be a difference in the delay of gratification, the time, because obviously with our research, we showed that each condition had the same amount of time that they were able to wait, like a very similar amount. And I expected children in the more positive emotion like pride and gratitude were able to wait a bit longer, but overall I knew that there would be a difference in some area, but it shows that it is in the strategies instead of the time. So
any other questions? All right. Well, congratulations on your research, Connie. Thank you very much.
Thank you.
All right. Claire, you can go ahead and share your screen and we will get started with your presentation at 2:23. Hello, everyone, and welcome to SRS Session 2, Zoom Room 1. We will have the next presentation in 1 more minute.
Can you see my screen all right? Okay.
Yes, we can see the screen and I could hear you.
Great.
All right, we now present Claire Semino, who will speak on perception of carbohydrates among college students. If you have questions, please put them in the chat box. All right, Claire, are you ready to present?
Yes, we are.
Okay, you can go ahead and go.
All right. So we are presenting perception of carbohydrates among college students, and I will be presenting alongside Jane Walters. Okay, our research is titled, like I said, Perception of Carbohydrates Among College Students. This research was performed alongside the help of Rebecca Doherty in the TCU Department of Nutritional Sciences. Jane, can you see the slides?
We can see your slide.
I think my co-researcher is having a little trouble with my microphone, but I'll continue. So the low carbohydrate diets have recently increased in popularity in the US. Despite having vital roles in the body, negative associations have been established towards carbohydrates in the media by indicating that reduced consumption leads to weight loss, decreased gastrointestinal conditions, and improved brain function and energy status. The objective of our study was to determine college students' perception of carbohydrates on health and the sources of these perceived views of carbohydrates. We hypothesize that due to recent media coverage and health trends, carbohydrates have gained a negative connotation in regards to health despite the lack of significant research supporting these ideas. We used SurveyMonkey to create an online survey. The survey was made available to TCU organizations and undergraduate students, as well as through the media platforms, including Facebook and GroupMe. After signing the consent form, the survey was 5 to 10 minutes long. We analyzed the data using Excel. The survey questions were broken down into knowledge questions and behavioral questions. Knowledge questions focused on recommending serving sizes of carbohydrates, the role of carbohydrates in the body, and carbohydrate-containing foods to assess the participants' knowledge level. Behavioral questions were geared around the participants' previous nutrition education, their diet history with carbohydrates, and their perception of carbohydrates, as well as of their caregiver growing up. The most commonly reported sources of nutrition education were internet searches, social media and blogs, and friends and family. It is important to note that approximately 45% of our participants were in a health-related major, and 47% have taken a college nutrition course. The majority of our participants indicated that in the past 5 years, their preference change towards carbohydrate-based foods has decreased. Among study participants, 45% have previously followed a low carbohydrate diet, and only 3% were currently following one. The primary effects reported from these diets are low energy levels, mood swings, and trouble concentrating. Of the participants who limited their carbohydrate intake, the main motivators were weight loss and health. To conclude, a small percentage of participants are following a low carbohydrate diet, likely due to their awareness of the roles that carbohydrates play in the body, as well as negative symptoms reported by those who previously followed one. Our study supports the role of nutrition education in dietary choices. While people often looked to education for the internet, while people often looked for education from the internet, it is clear that registered dietitians are crucial to the education of the public. That concludes our presentation. Thank you for listening. Does anyone have any questions?
If you have questions, you can put them in the chat box.
Thank you, Claire, for doing that presentation. I wasn't able to unmute myself until the end.
Jane and Claire, how did you guys get interested in doing research on carbohydrates?
Well, we're currently seniors in the coordinated program in dietetics here at TCU, and something that we are always learning about is carbohydrates, but something that you're always asked about as a nutrition major is, what do you think of carbohydrates? And you always hear about all the fad diets. So we were really interested to see what our peers at TCU were perceiving them to be and how they thought they affected your body and whether or not they really knew what carbohydrates were.
Awesome. There's another question in the chat. What do you suppose will motivate people to continue to adhere to a low carb diet?
To adhere to a low carb diet?
What will motivate people to continue a low carb diet?
I think low carbohydrate diet can also be a little bit confused with the ketogenic diet, which there is some studies, and we just hear of facts that it can help with weight loss, but it's not a good long-term method of weight loss. At some point it starts to plateau. So I think hopefully through our research and through other research that you want a balanced diet and you want a moderate portion of carbohydrates, as it should be about 45 to 65% of your diet.
Great. Congratulations on your research. Thank you.
Thank you.
All right, Kiana, if you'd like to share your presentation, we'll get started in 1 minute.
Are y'all able to see that? Amazing. Okay.
All right, we now present Kiana Gonzalez, who will speak on ethnic differences in parents' ability to identify internalizing symptoms in their children. Does their ability to identify symptoms in others matter? All right, go ahead, Kiana.
Okay, hi y'all. Like Dr. Cole said, this is what I'm going to be presenting on. And so just to start off, I wanted to give a brief background on what adolescent depression is. So depression is a mental illness that is characterized by a cluster of symptoms such as feelings of extreme self-criticism, loss of pleasure in past interests and activities, sleep problems, lack of energy and motivation, and increased thoughts about death or suicide. As well as depression, adolescent depression has adverse effects if not addressed in a timely manner, including increased risk for substance abuse, educational underachievement, teen pregnancy, social isolation, and suicidal ideation. And then in addition, a study done by Eaton and colleagues in 2007 found that higher rates of depression, or that there are higher rates of depression amongst Hispanic adolescents, as well as a study done by Gudino and colleagues in 2009 found that African American, Hispanic, and Asian American children are less likely to receive mental health services and experience more barriers to treatment than non-Hispanic white children. As for my current study, the goal is to determine whether parents of adolescents were able to accurately identify symptoms of depression in hypothetical adolescents and the extent to which their accuracy predicted their ability to identify symptoms in their own adolescent. And then just again, to give a little brief background, I'll be using the term internalizing symptoms. And so that's basically any inwardly experiences such as anxiety or loneliness that aren't always seen, since they can sometimes go unnoticed. So as for methods, we were able to get 74 dyads of mothers and their children. And for our children, we had 35 males, 39 females, 17 being Hispanic, and 57 being non-Hispanic. They range from 10 to 17 years old with an average of 13.73, so almost 14. And then for our mothers, we had 16 Hispanic, 58 non-Hispanic, with a little bit more than half being married. And then again, a little more than half having some either college degree or some college education. So for our procedure, we had the families come in and they did separate clinical interviews as well as the completion of questionnaires. So for our measures, we had child depressive symptoms being utilized with the strengths and difficulties questionnaire, which was just a self-report done by the child as well as from the mother's point of view, which ranged back for 6 months on the child's behavior. And then in addition, the mothers completed a questionnaire on vignettes, which were brief descriptions of 5 young people. And their task was to identify if they had any serious mental health problems, as well as what the concern for behavior would be. And then the vignettes kind of were just, it would be about, hypothetical adolescents in high school and a brief description about them that included their age, school activities, future career goals, and any other relevant information about their life, such as a change in relationship status, engagement in any risky behaviors, such as underage drinking, or going through any adverse life experiences, such as divorce. So for our results, the first graph here demonstrates the average worry for non-depressed vignettes. And what was interesting is that a higher score in this shows that Hispanic mothers actually had more concern for the hypothetical children who weren't had no actual signs of depression. So they were more intrigued about the adverse life experiences such as underage drinking, or that the child was having a divorce in their family. For the second graph, this is the average ratio of worry for depressed versus non-depressed. And a higher score here indicates that they're more worried about the depressed, and that's kind of what we want, as it demonstrates that mothers are able to identify internalizing symptoms in these children. Finally, we had the vignettes to predicting discrepancy moderated by ethnicity. And what we found here was that higher worry was associated with a greater discrepancy between the mother and child report of their own child's internalizing symptoms. And so for non-Hispanic mothers, they were in a sense almost too worried about their own child's internalizing symptoms. So just to sum it all up, Hispanic mothers were reported less worry for depressed children versus non-depressed children, as well as higher worry about depressed vignettes, higher worry about depressed vignettes predicted increased discrepancy between non-Hispanic mothers and children with internalizing symptoms. And so for clinical implications, we can see that mothers are a great source for clinicians in being able to identify their children's internalizing symptoms. And with that, they could team up and potentially create a more effective treatment plan for the child instead of just solely relying on the child's self-report. And then also that there are possible ethnic differences in the perception of externalizing behaviors. As mentioned earlier, Hispanic mothers were more concerned about the non-depressed children who were engaging in more risky behavior rather than the children who actually were showing signs of depression. As for the limitations, my sample size was smaller, so it can't be necessarily generalized to the public, as well as the sample size was taken from Texas, so that's only one part of the United States, so there could be just cultural differences with that. And then as well as just potentially a lack of cultural sensitivity. The hypothetical children described in the study all had very non-Hispanic traditional white names, so there could be a potential case of implicit bias going on when these mothers were reporting on the questionnaires. So for future directions, I think would be really interesting would be to look at this or to replicate this study, but use externalizing behaviors just to see if there's similar patterns that exist, as well as including more culturally diverse vignettes by just changing the names to get a better view of what their conclusions could come to, as well as having fathers participate in the study, as there are to just kind of essentially fill the gap the research gap that there is with fathers, and just kind of get them more involved as well. And then I'm open for questions.
All right, if you have questions, please put them in the chat box. Kiana, I have a question. Were you surprised about your results, or was that what you expected to find?
I was honestly surprised at first because I thought that originally there were going to be ethnic differences in just the mother's abilities to identify the internalizing symptoms in their own children, because there is just like the barrier to like Hispanic children getting mental health services compared to non-Hispanic white children. So I was pleasantly surprised, I would say, with that. But it was really interesting just to kind of see that there was a difference in how they looked at the hypothetical children.
Congratulations on your research. Thank you so much, Kiana. All right. Next up, we have Joe Vasquez. You can go ahead and share your screen. We'll get started in 1 more minute. All right, we now present Joe Vasquez, who will speak on Cloudy with a Chance of Stars. Go ahead and present.
Thank you for that introduction. I am Joe Vasquez. I am a first-year graduate student in the Physics and Astronomy departments, and I'll be discussing the research that I am currently doing with Dr. Kat Barger. So all around our galaxy, the Milky Way galaxy, there's all sorts of intergalactic stuff flying around. And one of these interesting things that are flying around are gas clouds. And one in particular that's very interesting because it's heading towards us is the Smith cloud. So the Smith cloud contains about 1 million solar masses worth of material, or 1 million suns worth of gas. And you can see the shape here, and as it travels towards the Milky Way, and the Milky Way is up here a little bit, in the top right corner. and we'll discuss that further. So why do we care about gas clouds in the first place? Well, gas clouds are very, very important for forming stars. So galaxies are eventually going to run out of gas. You can't make stars forever with the gas that you have. So if you don't want your galaxy to die out, you have to get your gas from somewhere. And one of those sources is gas clouds. So the Smith cloud in particular has a very interesting history. About 70 million years ago, it was ejected from the Milky Way in some violent event like a supernova. And right now, it is heading back towards the Milky Way galaxy. And in about 30 million years, it's going to impact our galaxy and then start making some stars. So it is traveling through a very, very high temperature, very diffuse gas called the galactic halo. And as it travels through that galactic halo, parts are being stripped off because it's going through a very high speed wind. Remember, it's going 100 kilometers per second through this galactic halo. And we're particularly interested in two places in the Smith cloud and looking at two different places. So previous studies looked at three different places, more towards the leading head of the cloud that's more dense, more densely packed together. And we're looking more towards the tail of the cloud that's more spread out. So these are the two places that we're looking at right here. And this is a map of the Smith cloud in neutral hydrogen. And this is more dense material over here, and this is less dense material over here. So we are using data from the Hubble Space Telescope to probe into the Smith cloud. So right here on the right is an example of the kinds of plots that we're looking at. And this is called a spectrum. Normally the x-axis over here would be color, but instead we are looking at velocity here. And over here is the ion, which is silicon plus. And the color is 119 nanometers. Here we have the Milky Way, and here we have the Smith cloud at their different velocities. And we want to look at the width. What is basically the standard deviation of how fast it's traveling. And we also want to look at the area above the curve in this best fit curve right here. And goals is we want to know the ionization conditions in those fragments of neutral hydrogen in the Smith cloud, as well as the trailing wake. And we also want to import these data that we are collecting and learn more about the Smith cloud through simulations and learn more about its temperature, its density in certain spots for the future. So here's my SciComm, and I'll take questions.
All right, if you have questions, please put them in the chat box. Joe, I have one. How did you get interested in this kind of research?
I've always loved astronomy, and gas clouds are just really, really cool things that, I don't know, they're just, galactic evolution is just very interesting to probe into and look at. Because it's basically how all of our stars forms and how galaxies form in general. If you know how galaxies form, then you get to stuff like our solar system and how we got here in the first place. So astronomy has just always been interesting to me for that reason in general. So I hope that answers your question.
Thank you. Does anyone else have a question? All right. Congratulations on your research, Joe. Thank you very much for a great presentation. All right, next up we have Viet Nguyen. And Viet, if you want to go ahead and share your screen, we will start your presentation at 2:47. All right, welcome to SRS. This is session 2, room 1. Let's see, we now present Viet Nguyen, who will speak on renewable energy, fossil fuels to renewable substitution, the effect of electric vehicles. You may go ahead and begin.
Yeah, hi, my name is Viet Nguyen, and I'm a junior in mechanical engineer. And my research is about the effect of electrical vehicles on renewable energy. So fossil fuel is partially shifted to renewable energy to prevent climate change. However, the solar and wind energy, they are periodically variable and intermittent. So oftentimes they are not available to satisfy the instantaneous demands of the customers. So energy storage will become an integral solution. And this study considered the possible role of electrical vehicles in a car grid, which supplies 92% of electricity on over Texas in 2019. So there's a demand and supply mismatch. It will shift from fossil fuel to wind and solar energy because they are periodically unavailable. So this problem represented by the duck curve that you can see on the graph, which include the current demand on the top and the lower supply curves by wind and solar. And my research estimate about 40 terawatt hours of electricity capacity for wind and solar energy to fill up the mismatch gap. And what is the roles of our electric vehicle? So our currently utility level storage is hydrogen, which is quite low charge and discharge efficiency. It's about 50%, but battery, they have a very high efficiency, about 90% for the round trip of charge and discharge. So there's approximately about 22 million passenger vehicles in Texas, and they consume over 370 millions of fossil fuels barrels a year. And if we replace half of these vehicles by electrical vehicles, we will need 55.4 terawatt hour of electricity annually. And these vehicles can supply 440,000 megawatt hour of battery capacity. So how can we bookkeep the flows of charge and discharge energy? And if supply is higher than the demand, we store the leftover of the supply in the battery first, and then send the rest to the hydrogen. And on the other hand, if supply is lower than the demand, we take out energy from battery first and then hydrogen. And these processes will include the charge and discharge efficiency. And we will pre-allocate an amount of hydrogen storage to make sure that there will not be any outage during the year. So after different parameters of efficiency, battery capacities, the ratio between wind and solar energy to study their behavior. We have two of the graphs that can sum up our findings. So without electric vehicles, the dissipated energy shown in the blue line on the graph, it can go up to 50 million megawatt hour. However, if we include the electrical vehicles with about 440,000 megawatt hour of battery capacity, we can reduce the dissipated energy down to 40 million, which is about 20%. So within the batteries, the generation of solar can be reduced by half because we can save solar energy from the sunny days while we don't need them, and then we use them in the deficit time later when the supply is lower than the demand, instead of wasting the solar energy. So as a result, the total energy supply on the yellow line on the graph, it can increase like significantly. And besides our effect of electrical vehicles in energy storage, we can increase the round trip efficiency to reduce the dissipated energy. So from 75 to 85 battery efficiency on the first graph, the annual dissipated energy can be reduced by 10%. And from 35 to 60% of battery efficiency on the second graph, the annual dissipated energy can be reduced by 50%. So in conclusion, we need a large storage capacity for the transition to renewable energy. And electrical vehicles potentially can provide 1 to 2% of the needed storage capacity. And even 1% of storage of electrical vehicles can significantly reduce the dissipated energy. And then we can improve the electrical vehicles round trip storage efficiency to offer great advantages. And research and
all right. Good job. If you have a question, will you please put it in the chat box? I have a question on your conclusion, the second one.
Yep.
Could you explain a little bit more about how electric vehicles can potentially provide 1 to 2% of the needed storage capacity, and kind of what does that mean for consumers?
So as you can know that solar energy and wind energy, they are periodically. Sometimes we have a lot of wind, sunny. Sometimes we don't have sun. Sometimes we don't have wind. So sometimes if we have a lot of wind and sunlight, but we cannot consume all of them, we need some source of storage to store them, to use them whenever the deficit happens. So for example, you see the outage over Texas like a couple of weeks ago. So we don't have any source of backup energy. So electrical vehicles, we can use those batteries from the cars as the backup of energy instead of consume fossil fuels energy.
That makes sense. Any additional questions? All right, congratulations on your research and what a great presentation. Thank you. All right, Kian-Wen, you will be up next. If you want to go ahead and share your screen, we will get started at 2:55 in 1 minute. Ken?
Hello. Matthew and Kim are in my group, and they're going to present for me.
Okay.
Yeah,
perfect.
thank you.
Thank you. All right. So we now present Kian-Wen, and who will speak on measuring the strength of AI agents in adversarial perfect information games. You may go ahead and present.
All right, thank you so much. Are you able to see the screen all right? All right. Well, good afternoon, everyone. My name is Matthew Boulding, and today I'm joined with one of my research partners, Kim Nguyen, and we will be discussing the strength of a Go plane agent, namely AlphaGo Zero. But before beginning, we need to take a moment and thank our advisors, Dr. Ma and Dr. Do, because without them, this project wouldn't have the solid foundation it currently does. The entire team thanks them very much for their tireless contributions.
Hello, everyone. So this poster actually the second poster of our research. And this one we focus more on the result, on what are we doing and what have we done. So there's some important concept you want to know about. The first is the Go game itself. Go is the zero-sum adversarial ball game for two players, where black play first. And the goal is to secure as much of the ball square as possible. And the co-mix is the compensation added to the white final score to compensate for going second. And we expect to see that the agent will play too aggressively when losing and too consecutively when winning. For the group of progress, the normal board size for the Go game is 19 by 19, but it's too complicated, so we scale it down to 5 by 5. And we found an optimal solution in the paper, so we try to compare it with our computer. And you can see it very consistent. Like if black play in the center as the first move, it will win 100% of the time. So next, Matthew will talk about opening move.
All right. And right, so moving on to opening moves. One other observation that we've made is that not only can our agent identify the optimal two opening moves, but it can play optimally for an extended period of time. The two boards on the left, although their 11th move does differ, show two equally optimal lines of play, and their difference does not affect the end result of the game. Black will eventually conquer the board. And moving over to the right 6 boards, we found that the agents tend to gravitate their opening moves to the center, which follows an optimal line of strategy. And it finds those optimal moves within 15 generations.
So for the optimal solution, after we succeeded with 5 by 5 board size, we move on to the 7 by 7 board size. And we have found 5 optimal solutions on a paper. So again, we try to compare it with our computer play. As you can see in the graph, the horizontal line represents from the early game to the late game, and the vertical line will represent for the how much of the similarity between the computer plays and the optimal move. So as you can see, in the early game, they're very similar, but in the late game, they are totally different. So it proves that our theory is correct, that the algorithm currently is not perfect. The agent tend to play very aggressively when losing and very consecutively when winning.
Right, so and in order to analyze some of the deficiencies of the agent, we gave it puzzle solving tasks. From the above graph, it's quite clear to see that the agent was stumped and dazzled by some puzzles, while it solved other puzzles correctly every time. In an attempt to counteract the agent's poor solve rate on some puzzles, we injected some of them into the agent's training process, a method which we call targeted training. We didn't provide the agent solutions to the puzzles, but rather just fixed game states from which it would continue to play. Although this addition to the training process does affect the agent's tabula rasa style of training, it significantly made the agent more able to solve puzzles than without, as shown by the lower 2 graphs. Only on 2 of the puzzles did the targeted trained agent perform poorly. However, this is still a significant increase from the self-play trained agent.
So in conclusion, on the 5 by 5 board, we successfully found optimal plays. We demonstrated on the 7 by 7 board that we could enhance the performance of the AlphaGo Zero agent by targeted training, by inserting specifically formed puzzles into the training process to enhance its performance. For the future work, we will design a more precise and robust evaluation system, and we are finding methods to enhance the performance of our playing agent. So that's the end of our presentation. Thank you for listening.
Good job. If you have a question for this presentation, please put it in the chat box. Kim and Matthew, how did you get interested in doing this type of work and this type of research?
I can go first. I was actually in an office hours with Dr. Ma discussing something about class, and he asked me what I was interested in. And artificial intelligence was one of my interests that I mentioned. And one thing sort of led to another, and he invited me to be on the research team, and I accepted wholeheartedly, and I'm really happy to be a part of this group.
Yeah, and for me, I knew Dr. Ma from my first term at TCU by attending his class in Linux system. So he knew me as well, and he invited me to the team.
Do you think, here's a question from the chat, do you think the level of improvement will extend to a 19 by 19 board?
For the complexity level, I think eventually we can reach that, but the hardware, I think the hardware level of complexity is very different. Like from 7 to 7, actually for the 9 by 9 it's already difficult.
All right, are there any other questions? All right, congratulations on your research, and what a great presentation. Thank you.
Thank you.
All right, next we have DeAndrea Veals. DeAndrea, you can go ahead and share your screen, and we'll get started in 1 minute.
Can you see my screen? Okay. All right, just let me know when I can start. Okay, so hi, my name is Dion. Oh.
1 second, sorry, we wanna make sure that we start at 3:03, so if anyone wants to see it's come into your presentation, they don't miss it. Sorry,
Gotcha.
Just wait just 1 more minute. All right, we now present DeAndrea Veals, who will speak on synthesis and characterization of an iodo-substituted macrocyclic complex, comparison of pyridine modification. All right, you can go, thank you.
All right, thank you. So I'm gonna start off talking about what are pyridine macrocycles. They can be considered a class of tetraaza compounds, which basically means that they have 4 nitrogen groups and they're connected in a cyclic structure. And they also contain this pyridine group as shown here. Some of the application of pyridine macrocycles involve MRI contrast imaging, neurodegenerative therapeutics, as well as catalysis. And all of these are important because they have to do with the pyridine macrocycle's ability to bind to certain metals. So what are some variations of pyridine macrocycle structure and how do they impact metal complexing? Well, the research group I'm a part of focuses on the modification of a pyridine macrocycle in the carbon 4 position as shown here by this pink X. And some of these substitutions include electron withdrawing groups versus electron donating groups. And so an electron withdrawing group just pulls electron density from a copper center and pulls it to the pyridine part of the macrocycle, while electron donating group pushes electron density to that metal center. I focus specifically on the synthesis of an iodo-substituted pyridine macrocycle. And I want to be able to study the characteristics of this compound in a simple environment so that we may be able to correspond these characteristics to a more complex environment, such as how it behaves in a human body. In addition, I've focused on the metallation using a copper metal because this metal has biological relevance in the human body, particularly in the human brain. So to start off, I focused on how the iodo impacts the electronic environment of a pyridine macrocycle. And I can do this using a proton NMR analysis. So I focus on the aromatic protons on the pyridine macrocycle, and we can study how these different substitutions impact the proton shifts. So if you have an electron withdrawing group, your shifts are going to be more to the left side of your screen or downfield, versus an electron donating group is going to be more to the right side of your screen or upfield. And we compare this to the neutral environment of a proton pyridine macrocycle, as shown here in yellow. So analyzing the iota, we see that it's shifted to the left or downfield, which signifies that it's acting as an electron withdrawing group. And so in addition, I study the metal and donor atom binding of the copper metal to the iota pyridine macrocycle. And I do this using UV visible spectroscopy. And so we can verify that the copper is in fact bound to the iota pyridine macrocycle based on certain absorbances at 260 nanometers and around 700 nanometers. And if we see these absorbances, then we can verify that the copper is bound to this iota in the way that we would expect. And so next up, I studied the crystal bond lengths and bond angles of the iota pyridine macrocycle when it's bound to copper. And I did this using X-ray diffraction. And so what's interesting to note is if you have electron withdrawing groups in that carbon-4 position, the bond length between nitrogen 1 and copper 1 is going to be longer than if you have an electron donating group. That bond length is typically shorter. And I saw with the iota group, it followed the trend of behaving as an electron withdrawing group, and that bond length was longer if you compared it to like the neutral environment. And so lastly, I wanted to study the copper metals reduction and oxidation activity, having that iota group in that carbon-4 position. And so I did this using cyclic voltammetry. If you look at the x-axis, you have potential, and on the y-axis, we have current. So if we follow the graph and you see an increase in current, that denotes a reduction event or the gaining of an electron. Copper 2 is going to copper 1. If we follow the graph around and you see a decrease in current, that is noting an oxidation event or the loss of an electron going back to copper 2. Having that iota electron withdrawing group in that carbon-4 position means that it requires less potential in order to achieve a reduction event. Versus electron donating groups typically require more potential in order to achieve that in order to achieve that reduction event, sorry. And so in conclusion, I saw some differences between the iota pyridine macrocycle's behavior and the chloropyridine macrocycle. And that's interesting because the chloro and the iota belong to the same group on the periodic table, the halogens. And so we'd expect to see similar trends in their capabilities, but we don't see this. And that may signify that the chloro is having some other factors impacting its behavior. Further applications of the iota compound is that it can be used as a gateway molecule for other substitutions on the pyridine ring, such as if we wanted to add more carbon groups. Thank you. Are there any questions?
If you have a question, please put it in the chat box. D'Andrea, how did you get interested in doing this type of research?
So I originally got interested because the Green Research Group kind of focused on some of the ways we could treat Alzheimer's. And so I was interested in like, how are these compounds working to do stuff like that? And I found out it had to do with that metal binding that I was talking about earlier. And so I really wanted to get involved and see what I could do to contribute to that type of research.
And do you have plans to continue this area of study?
In a way, I'm going off to medical school in the fall, so hopefully I'll be able to, apply some of the information that I've learned here into my studies.
Excellent. Well, congratulations on your research, and thank you for an awesome presentation.
Thank you.
All right, next up we have Jesse Mugisha. We will start your presentation in about 2 minutes if you want to go ahead and share your screen.
Sure, thank you. Can you hear me clearly?
Yes, we can hear you.
Good. And can you see this better, like high resolution, or should I zoom in?
We can see it very clearly.
This is good news. So much good news for one day.
Yeah. All right, I'll introduce you in 1 minute. We'll get started.
All right, sure.
If you're just joining us, welcome to SRS. This is session 2, Zoom room 1. All right, we now present Jesse Mugisha, and he will speak on fungi-induced alterations on plant biomass, impacts on carbon sequestration potential, and pollution control. You may go ahead and get started.
Thank you very much for the wonderful introduction. Now, as we know, microbiodegradation, or simply the way different microorganisms alter organic matter and environment, plays a major role in climate change and chemical pollution, basically by the way they process nutrients and recycle different nutrients in the environment. And thus fungal activity on plant biomass usually alters the molecular structure and their susceptibility to degradation in the environment, mainly by the way they degrade them by respiration and chewing on each of these organic matter in the environment. So knowing that in mind, my study focused on the way mold, or like fungi, changes the molecular structure of coffee mold as a model for the plant biomass in nature. We thus collected samples of coffee that molded from 0 months to 7 months, and then investigated how, if any, were the changes that the fungi made to their molecular structure and the ability to attach themselves to heavy metals or organic pollutants in the environment. So the first figure shows the change in the carbon content versus the stability across the time of molding. From the results, we see that as a function of molding time, we lost about 10% of the carbon content in these coffee samples, but we also gained a high R50, which is simply a measure of the stability of the remaining carbon that was found in these coffee samples that were molded. So as a result, we concluded that the fungal activity increases the carbon resistance to the degradation, thus improving the carbon sequestration, and also they may also present a solution to climate change. In other words, as the resistance of the carbon increases, it means that these samples are able to withhold the carbon from it being oxidized to carbon dioxide, and thus cutting the input of carbon dioxide to the atmosphere. But then we're also interested in figuring out what is the chemistry behind this stability that we noticed in the thermal investigation. And thus we conducted an NMR study, which simply shows the different functional groups in these chemical structures of the coffee samples that were molded from 0 to the 7 months. The results show that the fungi consumes methyl groups, or otherwise known as CH3, faster than the aromatic groups. This could mainly be explained by the chemical bonds that exist in methyl groups versus the ones that exist in the aromatic compounds. Methyl groups simply have weaker bonds that make them easier to consume or to degrade versus the aromatic compounds, which have pretty much stronger bonds. And thus the fungi prefers to save its energy and first consume the weaker bonds in the methyl groups and then head on to the aromatic compounds. So knowing that the persistence of aromatic compounds was noticed in these coffee molds, we concluded that this may explain the increase in the thermal stability or in the stability of the carbon that we noticed in the first graph. It simply means that the increase in the stability or the resistance to degradation may be explained by the strong bonds in the aromatic functional groups that exist in the remaining carbon after the fungi has consumed other functional groups. We also noticed a consistency in the negatively charged carboxylic groups, which are simply RCOO minus, and the main focus here is the negative charge among the functional groups that remained as a function of molding time. Knowing that it is negatively charged, we're like, okay, negative charges usually attract positive charges. So could we use this to advantage to also solve the problem of chemical pollution in the environment by simply reacting anything positively charged with the carboxylic compounds in the coffee mold to see if anything, there would be an absorption. We therefore used ginger and violet used in many processes to react it with the coffee samples. And then we investigated the absorption rates and absorption analysis using UVVS. We thus concluded in the first phase that the plant biomass stability and absorptive capacity were driven by the presence of the strong bonds, as mentioned earlier, and negative charges in the residual functional groups, respectively. So to investigate the absorption analysis between the coffee molds and the ginger and violet, we observed a linear relationship between the concentrations of ginger and violet and the amount of ginger and violet that were absorbed by each amount of the coffee samples that we shook it with. And based on the analysis of these trends, we realized that the removal efficiency, which is represented by the last figure here, generally decreases all the way from 0 math to 7 math, but then spikes up from 5 math to 7 math. And a possible explanation for this trend may also be explained by the presence of the carboxylic group. If you can notice here, the carboxylic group is generally decreasing from the 0 to 5 math, but then from 5 to 7, there's a higher increase. So in other words, there may be more presence of negatively charged functional groups that were availed after the 5 math for them to attract to the ginger and violet, which is positively charged. And therefore, it increased the removal efficiency across molding time. In a nutshell, the fungal-induced alterations in plant biomass may increase carbon sequestration by locking carbon to themselves and also improve the capacity to remove cationic pollutants, in which we use ginger and violet as a model. For the future purposes of my study, I will investigate how the pH may influence these absorption rates and capacity, and also conduct further kinetic studies to see, besides knowing how strongly these compounds bound together, how fast can they remove ginger and violet from the environment. And that also, in a nutshell, explains the possible solutions to climate change and chemical pollution, simply saying that fungal-induced alterations may improve carbon sequestrations, thus solving climate change in part, and also help to solve chemical pollutions by absorbing this material from the environment. Thank you.
All right, thank you, Jesse. If you have a question for Jesse, please put it in the chat box. All right. Congratulations on your research, and thank you for a well done presentation.
Thank you very much, Cassie.
All right, welcome to SRS. You are in session 2, Zoom room 1. Our next presenter will be Charles King. If you'd like to go ahead and share your screen, I'll introduce you at 3:19. All right, we now present Charles King, who will speak on continued monitoring of land subsidence in Mexico City using INSAR. You may go ahead and begin. Charles, we can't hear you. There we go.
Am I good? Oh, thank you. Thank you very much. So as previously stated, my presentation is about the continued monitoring of land subsidence in Mexico City using INSAR methodologies. So a little bit of background on what is INSAR. INSAR is interferometric synthetic aperture radar, and this process works by calculating the phase differences of radar signals that are reflected from the Earth's surface over a period of time. If the land has uplifted or subsided, the phase of the two radar signals will interfere, and the magnitude of difference between the two phases can be used to determine how much the land below has moved. So in the case of Mexico City, there are two main reasons as to why the ground is subsiding. The first is due to Mexico City's unstable geology. This is due to two different sediment types that are on a gradient. In the foothills of the city, on the outskirts, there is a fine volcanic deposit type of sediment. And as you move towards the center of the city, it is the sediments are composed of lacustrine clays. And so both of these sediment types are susceptible to drying and compacting. And as as Mexico City's need for water is increasing, groundwater is being pumped from below the city for use. So as the groundwater is being pumped, these sediments are being dried and compacted and subsequently causing deformation and subsidence and taking Mexico City down along with it. So the objective of this study was to quantify the land subsidence of Mexico City from 2019 to 2020. So now we're going to go into a little bit of the methodology. For initial processing, radar imagery was obtained from the Sentinel-1A mission, and the processing to create the interferogram, as shown on the right-hand side here, was conducted through the SNAP program. The following interferogram is displaying fringe patterns, and the fringe patterns represent a full 2π cycle shown in a cycle of colors. And one cycle of colors represents a subsidence amount equal to half of the wavelength of the sensor. In the case of Sentinel-1A, that is 2.2 centimeters. But from this image, you cannot really tell what's going on. There's not a lot of information to be had here. So a secondary step of processing needs to occur. And that would be a process called phase unwrapping. And because the sensor gives us the data in a 2π cycle, not all the data is usable. It's constrained, and so the process of phase unwrapping uses an algorithm to remove this 2π restriction. And this does two things: it allows for the interferometric data to be related to elevation and topography, but it also smooths the data for a more accurate interpretation of the subsidence across a gradient. And so our result is this picture here. The interferometric data was taken and overlaid over a map of Mexico City. And we can see in the center of the city, there's a ground subsidence rate of about 29 centimeters per year. And as you move away, it declines in a gradient. And in the outskirts of the city, there is a subsidence rate of about 4 centimeters per year. So what are the major threats associated with this subsidence? Well, 15% of the population lives in areas where the rate of subsidence is fast enough to be considered high risk. And this is because major structural failures of housing could threaten the lives of 1.5 million people in these high risk areas. And these are the areas that lie in the foothills of the city where the geology is primarily the volcanic rock and sediments. And the strain caused by the differential rates of subsidence across the city causes fissures in the rock, leading to the structural damage. And additionally, the subsidence of the gradient of subsidence causes a concave land surface in the center of the city, which collects and ponds water, posing flood risks for over 750 properties in the city. And this risk is most prominent in the center of the city because of the compression of the lacustrine clay, which reinforces the concaving land surface. It doesn't quite become brittle and crack like the volcanic rock, but because these clays can compact, it creates that dome shape that allows the water to flood and pool. And so in conclusion, the subsidence rate of Mexico City from November of 2019 until the November of 2020 was approximately 29 centimeters at the central portion of the city and decreases to about 4 centimeters per year towards the outskirts of the city center. These results indicate that the subsidence of the city is continuing at a rate that is similar to what has been observed during previous studies in the past. And to make the study better, or to improve the study and move forward, further processing via stacking more of the interferometric data could refine the measured rate, because in my study, I only used 2 data points, but more data points over the course of a year could be used to help pinpoint the rate of subsidence to a greater degree of accuracy. And additionally, other satellite missions such as GRACE could help to monitor groundwater levels and aid in tracking subsidence of not only Mexico City, but of other places around the world where this same exact event is happening. And hopefully in those cases, we can help to slow this rate and even hopefully stop it. And that is it. thank you for listening, and I'll take any questions.
If you have questions for Charles, please put them in the chat box. How do you help this problem? What are some recommended steps once you find out that this is happening? What can you do about it?
Well, that's an extremely difficult question, because in the case of Mexico City, it's from groundwater pumping, and there's been efforts to do this. Mexico City's idea to help remedy this problem was to take wastewater that they had from the city and to repump it back into the ground to help try and slow this. But that is ineffective, because the rate at which they're pumping the groundwater is actually greater than the rate that they can put it back in. And so this is actually an offshoot of a much bigger problem that we have in terms of getting water to cities that may not have the resources necessary to get it. And this is obviously an ongoing problem. And I don't think that I necessarily can provide a great example or explanation as to how to stop it. So it's going to be an ongoing problem. And hopefully by using more precise data and coming together with other missions and satellite data, we can at least help to slow this process or even stop it for cities that are experiencing the same deal, but not at such an advanced rate like Mexico City.
Gotcha. Thank you. All right. Congratulations on your research and a well-delivered presentation. Thank you.
Thank you.
All right, next we have Evelyn Morales. And Evelyn, if you would like to share your screen, and then we will start, I'll introduce you at 3:27. All right, we now present Evelyn Morales. She will speak on the interactions of environmentally significant anti-inflammatory drugs with nanocrystalline iron oxides. You may go ahead and begin.
Hello, so the anti-inflammatory drug that we looked at was ibuprofen. If you look at the structure right here, it has a carboxylic acid, and the importance of this is because its pKa is 4.43 plus or minus 0.03. And ibuprofen was important to look at because it is widely used as a pain reliever, and it also has a high consumption rate with and without prescription. So it is also found in rivers and estuaries. And in this diagram, if you also look right here, we looked at ferric hydride, which was the nanocrystalline iron oxide. And we used it because it has a high surface area and is also found in soils. And its reactivity enables it to sequester various species like ibuprofen and the nitrate that you can see right here in the diagram. I use sodium nitrate because nitrate I was able to put it into the surface of the ferric hydride, and this would allow me to have the surface to be occupied. And then once I added the ibuprofen, what we were looking at is to see if it could be displaced from the ferric hydride surface. So the ferric hydride at pH of 5, we chose that one because it's close to the rain pH. The ferric hydride has positive charges, so then this nitrate would be on the surface and it would occupy it. Then we would add the ibuprofen, and at pH 5, since the ibuprofen would have a negative charge on its carboxylic acid, so then it would go onto the surface. And then again, we would do the same cycle where we added nitrate, and we hypothesized that these charges would be able to displace each other. So the nitrate would displace the ibuprofen from the surface, and so on and so forth. So the hypothesis is that this negatively charged ibuprofen will interact with the positively charged ferric hydride surface. So how did I study that? I looked at the ibuprofen and replacing nitrate through the UV vis. So we monitored the concentration of the effluent, and what you're looking at right here is the spectra of ibuprofen, and we looked at the wavelength of 250 nanometers. So as we looked at these different, the cycle, we looked at how we determined the quantity absorbed, how fast it was being absorbed, and how it's being absorbed. So these peaks right here, this left side is ibuprofen being absorbed or ibuprofen replacing nitrate, which is this left side right here on this diagram. And then the right side is ibuprofen desorption. So this nitrate replacing the ibuprofen. So that's this right side. And this all again tells us the quantity absorbed and how fast it was absorbed and how it's being absorbed. So now after we graphed the data, we looked at the ibuprofen absorption. So these shapes tell us how it's being occurring. So how fast and how it's being put into the ferrihydrite's surface, and then the desorption, how the nitrate is replacing this ibuprofen. And the shaded area tells us how much is being absorbed and how much is being desorbed. And this ibuprofen absorption, we also see how fast it's coming on. And these graphs also show us that this particle size didn't matter and it didn't change the rate or how much was being absorbed. And this occurred in two different stages. Stage one was the ibuprofen going into the surface of the ferrihydrate, and stage two was the ibuprofen being diffused inside of the ferrihydrate pores. And then the desorption was the nitrate replacing the ibuprofen. So this taking it off only occurred in one stage in one rate. So if we look at the stage one, where it's being placed into the surface of the ferrihydrite, we see that 60% is being absorbed into the surface and 40% was diffused inside of the pores of the ferrihydrite. And this stage one was faster than the stage two. And the desorption was faster than stage two, but it wasn't as fast as stage one, which was a diffusion. And again, which was it going into the surface. The diffusion was stage two, and that one was slower because again, it's going inside of the pores. So then we look at the derivatives of these graphs, and we see that in stage one, this one is telling us that it's going at a faster, sharp drop. This is the 60% that went into the surface, and the right side is the 40% that went inside of the ferrihydrite surface, of the ferrihydrite into the pores. And we see that the absorption was almost as fast as the first stage. And again, the particle size did not change the rate or how much was going inside into the ferrihydrite. So future studies, we looked at other pharmaceutical drugs, and we looked at triclosan, which was not mentioned here in this presentation. Thank you.
All right, nice job, Evelyn. If you have a question for Evelyn, please put it in the chat box. We have about 3 minutes for questions, or 2 minutes. Evelyn, what are some future directions of this research?
So basically, again, looking at triclosan, we didn't get to finish everything. We looked at ibuprofen, and there's also menagestrol acetate. That's another one that we could possibly look at. We're using ferrihydrite to remove it from water. These are 3 prevalent ones that we found looking at reading other articles and journals that were also prevalent in rivers and estuaries and other aquatic environments.
Any additional questions for Evelyn? All right, congratulations on your research, Evelyn, and a well-done presentation. Good job.
Thank you. Thank you.
All right, next we're going to have Andrew Hudgens. I will introduce you at 3:35, but you can go ahead and share your screen, Andrew. If you're just joining us, welcome to SRS Session 2, Zoom Room 1. We will have our next presentation at 3:35.
I have an issue sharing my screen. Any advice?
Okay. Let's see. Try it again.
I apologize.
Chelsea, are you available to help?
Yes, as of right now, he should have the ability to share his screen.
Okay, I got it.
Excellent. All right, I will introduce you right now. It just turned 3:35. All right, so we now present Andrew Hudgens, who will speak on spatial variation of sediment sources and its implications. You may go ahead and start.
Okay, I did a detrital zircon study of the Stanley group that was deposited in the Ouachita Trough. And the purpose of this study was to kind of, previous research has been inconclusive on the sediment source from whether it came from the Appalachian Mountains, northern Laurentia, or from a southern arc or the southern continent of Gondwana. And so a quick geologic background: in the late Precambrian supercontinent, Rodinia started to rift apart, separating Laurentia from Gondwana. The yellow circles up here are the location of the Ouachita Trough. As you get into the late Mississippian time, Gondwana is starting to encroach Laurentia, and sediment influx into the Ouachita Trough increases. And the Stanley Group is the first increased sediment deposit that is formed in the Ouachita Trough, suggestive of an encroaching continent to the south. And so the samples I took are here in red. I took them from turbidite deposits in the Stanley Group, ranging from 8 inches thick to almost as thick as 4 feet thick. And these are deep water plastic sediments. And these samples were grinded and powdered, and zircon grains were removed from the samples. And the thing about zircon grains is you can precisely date the age of the grain. And in this next slide, this is kind of showing how North America Laurentia is broken up in age group, and they are considered sources of sediment that could have been deposited into this Ouachita Trough. So when we look, these are my results from my 9 samples, defining whether sediment is sourced from Gondwana or Laurentia. The biggest differentiators from the two you can find is there was limited magmatic activity in Laurentia during the Neoproterozoic, which is between 500 and 800 million years old. And also there was limited activity between 1900 and 2200 million years old. So if we look at all these samples, you can see a clear, distinct change from the top 6 here to the bottom 3, suggesting there's likely a separate source of the Stanley Group during the late Mississippian. I compressed the samples I had based off an MDS analysis showing how similar samples are to each other. Group 1 is this upper sample in this study. Group 2 is this lower sample. And it's showing that of all the samples taken, it can be broken up into whether Laurentia was a dominant source of sediment, or Gondwana or the Maya block to the south was the primary sediment or primary source of sediment. And so it's just showing how again, with like the granite rhyolite here, which is a central Laurentia terrain, is very prominent, and the Yavimosel is present. And so they're good indicators of a Laurentia sediment. And in the group 1 sediments, you see a lack of mid-granite rhyolite, a lack of Yavimosel terrains, and an increase in the Neoproterozoic terrains. So when we go to this is a map of coeval strata, or deposits that were laid down in the Mississippian across Laurentia. And the biggest thing to take away from this is group 1, which we're saying is sediment is coming from the south, has a strong Neoproterozoic signature. And group 2 has almost no Neoproterozoic signature. And if you're looking at all the signatures across Laurentia, there's really a lack of Neoproterozoic age grains in the Mississippian, suggesting that the most likely source is from the south. And then this is the proposed sediment dispersal pattern. During the late Mississippian, previous studies in yellow, Gerald shows east to west sediment transport. weighing in 2019 showed that we had incised valleys coming off this main river system flowing to the south. And then the orange is my added additional sediment source, or paleo sediment dispersal pattern from my study, showing that we're getting sediment both contributed from Laurentia and from the south in the Maya block.
All right, if you have questions for Andrew, please put them in the chat box. What's your next line of research? Are you going to follow up with this same area, or where do you?
So what I want to conclude to do is, because basically I've just looked at the samples grouped up into this group 1, group 2. But when we look at the previous samples, you can see there's a huge variation in total age populations throughout the sample. So I want to look to see if there's a variance in each sample and try to see if there's local sediment transportation.
Let's see, any other questions? We've got about another minute. All right, congratulations, Andrew, on your research, and well done presentation. Thank you. All right, if you're just joining us, welcome to SRS. This is session 2, Zoom room 1. We have one more presentation, which will get started in just 1 minute. Let's see, let me go ahead. All right, and can you tell me how to say your name?
Benit.
Benit. Okay, and how do you say your last name?
Ishimge.
Ishime? Okay, thank you. I didn't want to get it wrong. All right, you can go ahead and share your screen, and then I'll introduce you in about 1 minute.
Can you see my screen?
Yes, we can. Okay, we now present Benit Ishimwa, who's going to speak about the correlation between industrialization, urbanization, and heavy metals contamination in Rwanda, a case study. All right, you may go ahead and start.
Hi, everyone. My name is Benit. I'm a senior, and I'm an environmental science major. So I've always been passionate about learning how human activities affect our planet. So as global population increases, we have seen a rapid growth of industries and a big shift from rural to urban dwelling. This has changed both the physical and chemical structures of our surrounding environment. Some physical changes that you might be familiar with can include deforestation for agriculture, or trying to find housing for growing populations, or in chemical changes can include the release of chemical contaminants from our industries into atmosphere or our surface waters. And for my study, I chose to focus on chemical contamination. And more specifically, I chose to look at heavy metals. So over the course of my project, I posed myself the question: what is the trend between heavy metal pollution in a fast, urbanizing, industrializing, low-income country? Some common characteristics of low-income countries when it comes to heavy metal contamination include not having regulation in place for heavy metal contamination, prevention, or monitoring, or just simply not having the infrastructures, resources, money, and technology to deal with the contamination, removal, and cleanup. So for my study area, I chose to look at my home country, Rwanda. So Rwanda is a country located in Central East Africa. It's a very small country of about only 10,000 square miles. As of 2021, Rwanda is housing about 13 million people and is considered to be the second most densely populated country in Africa. Surface water is the main source of drinking water and irrigation water in Rwanda. So for my study, I had 4 objectives. My first objective was to find if there is a correlation between urbanization, industrialization, and heavy metal contamination. My second objective was to find the areas with the highest heavy metal contamination in surface waters. My third objective was to see if there is a variation of heavy metal concentration over time and how it's affected by precipitation. And my fourth objective was to see the size of the population exposed to contaminants. So let me zoom in my figures so you guys can be able to see it. So using satellite images, I was able to see that there was a big change in land use and distribution in Rwanda over time. As you can see in 2007, represented in red are urban areas. Only 6% of the country was covered in urban areas. And by 2020, 13% of the country was covered in urban areas. And this had a very big effect on the amount of heavy metal released into surface waters due to fast industry growth and urbanization. And if we look at the progress of heavy metal concentration into surface waters, using these figures, I want you to retain 3 main things from these figures. First, we're going to look at how the concentration has increased over time. And I don't know if you can see well, but if you look at these heavy metals, lead, chromium, iron, and manganese, you can see that the concentration in waters has increased over time. I started to look at 2007, you can see that the concentration is very small. As you go over the years, the concentration has increased in the surface waters. This is a very serious problem because people are using this water for drinking water and for daily activities. The second thing to look at is that the concentration of heavy metals exceeds the World Health Organization guideline for maximum permissible limits for surface waters in all the surveyed areas. So you can see that all the heavy metal contamination is above the World Health guideline. And the last thing to see from these figures is that precipitation has a very big effect on the amount of heavy metals in surface waters. So this means that as it rains, rain washes out heavy metals from contaminated sites into surface waters. And this is a very serious issue. So my last thing that I wanted to look at is the number of people that are affected by or they are consuming either directly the water that's contaminated or indirectly through using the water in agriculture or in daily activities. So using a classification, I found out that in 2007, about 900 people were using contaminated water in Rwanda. And by 2020, this number increased to 1,500,000 people. So as a conclusion, I found that people who are living in urban areas are the most affected by, are the most exposed to heavy metals, and that there is a big correlation between urbanization, industrialization, and the amount of heavy metal released in surface waters. So as a conclusion, low-income countries like Rwanda are dealing with this kind of a problem, and it's an issue that needs to be addressed by their local government. Thank you. If you guys have any questions, you're welcome to ask.
Yes, if you have any questions, please put them in the chat box. I've been to Rwanda twice and it's beautiful. I'm wondering, what are your next steps? What's your plan? What are you going to do next to help solve this problem, if anything? No pressure.
Yeah, so one thing that I see that is mainly needed is waste waste management. As so many industries like car repair shops or like mining do not have regulation of how they're supposed to deal with their waste. So they just like let them sit there, and when it rains, so that's how you get most of the contamination in Rwanda. And Rwanda is a very hilly country, so most of those stations are on mountaintops, and like when it rains, all that waste goes into rivers and lakes. So I feel that's like the most important thing that we need to address. And I think the second one would be to try to find ways to clean up our surface waters, because as you saw, most of them are like have a very high contamination of with heavy metals. So those are the main two things that I can suggest.
Excellent. You have another question. How does the heavy metal poisoning affect pregnant women and how children develop?
That's also a very good question. Actually, this is the next step of my project. I want to see how people are being affected if there are reported cases in hospitals, because people are not addressing this problem. Like I try to find research or like people talking about it. Like no one is talking about how people are being affected by this problem. I guess it's because the country has so much more things to deal with that this issue is not being addressed right now.
Excellent. Well, congratulations, Benit, on your research and well done presentation. Thank you, everyone, for joining us. I would like to let you know that the award ceremony for SRS will start at 4 p.m. and you can find the link on srs.tcu.edu. Thank you very much. Bye-bye.